Okay, perfect. We are going to do a session on trigonometry. Oops, nice start. And from whatever course you might have come through to where you are working on trigonometry, there are some definite parameters around what we know about trigonometry. At this point, and only when you're way in the higher grades will you learn about working on trigonometry for non-right angle triangles. We have to have a right angle triangle. Later on in 20-2, actually, I shouldn't say that, we will work on non-right angle triangles, but for right now, all of our conversation is going to be on right angle triangles. So once we have that, there are a couple of things we need to review. I'm not going to spend a lot of time because we are looking at trigonometry from a kind of review standpoint. One thing to note, you will often see that the corners or the angles of a triangle are labeled with uppercase letters, and then directly across from those is the lowercase equivalent. You might just want to make a little note that A, B, and C, the uppercase. You will see this as you go through different references. These are used for the angles, the uppercase. And then the lowercase a, b, c are used for the sides. And we have to be careful here that they're directly across from each other. So if you're asked to, you know, say there's no diagram and you have to design your own diagram and get the letters in the right place, be careful of that. All right, once we have that little piece of information, let's draw one more right angle triangle and let's get into doing some trigonometry. I'll use A, B, and C again. But now let's go through the definitions. Like I say, this should be review. So hopefully we know that sine is identified as the opposite side. And I'll just use angle A as my reference over the hypotenuse. And cosine is identified as adjacent over hypotenuse. And tangent is opposite over adjacent. We're going to go and make sure we know how to label the sides in a minute. And the word, likely you've been introduced to this word. I would be surprised if you didn't know this word. We like in math to make up these odd words. But anyway, SOHCAHTOA is the word we use to try to remind us of what the definitions are so we don't forget them. Now, it's really important that we're able to identify which side is which. And we always do it in reference to the angle that we're dealing with. So I picked angle A, so I'm going to circle that. And so we're going to name our opposite and adjacent in reference to that. The hypotenuse stays stagnant or the same. So I always usually just identify the hypotenuse right off the get-go. It's the diagonal one across from the 90. And then we go and we say which side's opposite and which side's adjacent. So the way we determine that is we draw an angle, or sorry, a line right across to the other side, and across from is the opposite. And then the leftover guy is the adjacent. I'll just abbreviate him. So super important as you're going through, you don't have to write the big words, but I would write hype, ADG for adjacent and OPP for opposite as you're trying to work through making sure you know how to identify which trig ratio so that you can go and solve it. So once you're clear on whether you're working with sine, cosine, and tangent, there are two types of questions that we will deal with. And we'll set a few up and you guys will get a little bit of chance to do some questions and then just private message me the answers. One type is when we have to find a missing side. And then we'll do those. And the other ones are finding a missing angle. So we'll do those in a second. I'll just start fleshing out questions here. So let's do one and see that we're all successful. So I'm going to draw another right triangle. I'm going to tell us that this is 41 degrees. We'll put this as angle X. This is angle Y, and this is angle Z. And I'm going to tell you that the hypotenuse is 12 centimeters. Okay, so there's our setup. Now we're going to be asked to find side X. So this guy over here, I'll change my pen color. There we are. This guy's the one we're trying to find. So take a minute, figure out which trig ratio, and see if you can write the statement. So I'll just pause for a second and give you a chance to do that. And once you get your statement, just so I can kind of keep track, go down to the little chat bubble and just type me something, ready, okay. And if you're confused, you can tell me that as well. Remember, that will not come onto our recording, so you're just able to communicate directly with me that way. Okay, so let's have a look at it. I didn't hear from everyone. I won't pause for that long. We're just trying to move along and look at this. So when we go to figure out which trig ratio, I always identify which sides I'm given. This is the hypotenuse, and this is the opposite. So I sneak a peek back at SOHCAHTOA, and we've got opposite and we've got hypotenuse. So we're talking about a sine question. So then we write sine of 41 is x over 12. Now, to solve this particular one, what I do is I put a 1 underneath here, just so I have a ratio on both sides, and then I cross multiply. That by that and that by that. So then I get x is equal to 12 times sine of 41. Now, something that occurred with one of my students, be really careful that your calculator is in degree mode. So I'm going to do the calculation. You guys do it there as well. And if anyone doesn't get this exact answer, you need to let me know, because we're going to have to talk about putting your calculator in the right mode. So I get 7.87. I didn't tell you where to round off to, so we'll do it to 2 decimal places, and it was centimeters. Okay. If anyone doesn't get that, send me a quick little private message to let me know that you're having trouble. Okay, so in general, something that you might find helpful is this little note here. If the unknown is on top, we multiply. And you're going to see why that's important in a minute, because I'm going to set up a question where the unknown is on the bottom. And we're going to see that a little process happens that might help you kind of sort out how not to make mistakes on these. So we're going to do part B. We're still finding a missing side for our second question. I'm going to kind of change it up and flip the triangle around a little bit, see if I can. I'm not intentionally trying to confuse anyone, but might confuse people. And we'll do PQR. I'm going to give us that the angle R is 32 degrees. And I'm going to ask us to find the hypotenuse. So we want to find side Q. And I'm going to give you that this is 7.1 meters. Okay, so I gave you side P, I gave you angle R, and we're asked to find side Q. Okay, so do the same thing as we did a minute ago. Label what we're given, what we're asked for. So we're asked for this guy, if that's helpful to put Q right there. try to figure out which trig ratio is, and then again, send me a quick little message. I got a couple from people last time. Hopefully I'll get a couple more this time that tells me which trig ratio. And then if you can write the statement while we have a little pause here, that would be great. Anyone else want to share what trig ratio will work here? Yeah, remember, you're only sharing with me, so it's not going to go out on the recording. Okay, well, let's have a look at this. So we should identify which sides that we are given and know, and then try to decide from there which of them it is. So I'm just going to change my pen color. This is the hypotenuse. It's directly across from the 90 degrees. And now we have to be careful. If we do our little arrow across, that's the opposite. We don't want the opposite, so we only have to note that. It's the adjacent that's important. So I'm just going to kind of erase that because we don't need to know that. So A and H, again, if we go over here to our SOHCAHTOA, we're looking at cosine because we've got A there and H there. So A and H is cosine. So we start out by writing cos of 32. Adjacent is 7.1 and Q is the hypotenuse is on the bottom. So notice here that our unknown is on the bottom. So as we get going through, there's going to be a little more work to do here to get it ready. So we're going to still put it over 1. And we're going to cross multiply. I try to stay consistent. So it's Q times by cos 32 equals 7.1. And then to get Q by itself, so we can get ready to get our calculator out, we're going to divide. So our work will look like this. Now we get our calculator out and we divide. So when our unknown is on the bottom, we divide. Let's do this and make sure everyone can get the same answer as I've got. 7.1 divided by cosine of 32, 8.37. And I always like to kind of make sure, does that seem reasonable? Well, it's bigger than the 7.1, so certainly looks like it should work in terms of an answer. So let's put our little note here. When the unknown is on the bottom, we divide. And I'm going to put divide by the trig ratio. So if you're wanting to look at some shortcuts, I know that we got some bright cookies in here. You don't have to show this step in 20-2, 20-3. I'm totally cool. You could just go 7.1 divided by cos 32 and get the answer. Just be careful that the trig ratio is on the bottom. Don't go cos 32 divided by 7.1 because that'll go bad for us. Any questions? Okay, looks good. So now up here, I was saying there's 2 types of questions. Finding a missing side. We've done those types. Now we're going to go and do finding a missing angle. So let's draw a triangle here. ABC again, might as well go to. And I'm going to say that this is 7 centimeters. This is 9 centimeters. And I want us to find angle C. And SOHCAHTOA has kind of gone out of sight, but I can easily tuck it in here for us to use. Okay. So identify what sides we know and identify which trig ratio we're going to use. And then if you can write the starting statement, that's fantastic. And you can share what trig ratio you get once you've got that done. Okay, so that we're not lagging too long, I'm going to identify the sides. This is the opposite directly across from. Again, this is the hypotenuse, which we don't need, so put that in brackets. And so this is the adjacent. So we don't need the hypotenuse here, so we need the opposite and the adjacent. So I picked tangent on this one. So we write it this way, tan C equals 7/9. This is the starting statement. I know sometimes students skip this statement when they're trying to find missing angles, and I really like to encourage you not to skip this. Now, the next step, we need to ask our calculator to find the angle given this. And so we set up and we write this. Tan to the -1 is telling our calculator that we want to find out what angle will produce a tangent of 7/9. Now the calculator buttons, if you're not sure, and I'm working on one of these calculators, the TI graphing ones, 83, 84, one of these. If you don't have one of these and this doesn't work, you got to alert me to that so I can tell you your buttons. But your buttons here, you're going to hit the second function button first, and then the tangent button. It opens a bracket for you. Then you go 7 divided by 9. You can close the bracket, and then you hit enter. So I'll do that, and then I will entertain any questions or comments. So we get the answer, angle C is equal to 37.9 degrees. Often we round angles to the nearest degree, so we'll write it as 38. Good, good, good. We're getting some answers from people. Fantastic. Okay. Okay, so we've done the basics here. We've found missing sides, we've found missing angles. The one thing we haven't talked about that we should just briefly talk about is Pythagoras. Pythagoras is another way of finding missing sides if we don't have anything to do with angles. We're just talking about sides. Let's do a very brief look at Pythagoras. So let's make a little note. Used when we know, we know two sides, and we're asked for the third. Most students feel pretty good about Pythagoras. There is one real tricky part, so we'll do 2 questions here. This first one I don't think you'll find tricky. I'm going to call that X, and I'm going to say this is 7 meters, and this is 12 meters, and we're going to find X. And so when we do this one here, we're finding the hypotenuse. And so likely everyone here has been given Pythagoras to read a squared plus b squared equals c squared. Great way of writing it. I have lots of different ways I've seen it. Just be careful that you know that the c is the hypotenuse. The a and the b don't matter a whit. You can always use b as the bottom if you want, and a as the other one, the altitude, but it really doesn't matter. That's not going to be of concern. Hypotenuse is of concern. So we're going to rewrite this then as 7 squared plus 12 squared equals c squared. Now I would just grab, you can do it longhand, but I don't know, 7 squared plus 12 squared, I would just do all out at once in my calculator. Now I'm going to change the order or the sides because I like to have my unknown on the left-hand side. So c squared equals 193. And then just don't forget to take the square root of that, not the square of that, the square root. So again, if you want some calculator buttons for anyone that is struggling with their calculator, what you would do is you go second function and x squared. That will open you up a square root. It'll put square root on there. And then you can enter 193. I think it opens a bracket as well. So in here, so we'll put a bracket, close the bracket, and then hit enter to get your answer for square root of 193. Okay, so we'll do that. And we get 13.9 if we round it off. And I see I've got some more things to read. And watch your units. Don't lose a half a mark because you forget your units at all. Excellent. Thank you for these answers that are coming in. That one doesn't normally throw students for a loop, but the second one, let me just get rid of some of the previous stuff I had on here. The second one sometimes can. So let's do one more. Again, I think I'll write my triangle all wonky. Give us a bit of practice in that. So there's my right angle. And say we're given that this is 71 meters. And this is 22 meters. And we're asked to find y, say in this case. So again, what I mentioned was really important that we know which numbers are hypotenuse and which number, the other ones don't matter as much here. So this is our hypotenuse. Let's be careful. So a squared plus b squared equals c squared. Again, the a and the b doesn't matter. We're trying to find the missing one. So we'll go 22 squared plus y squared equals 71 squared. Now, when we're trying to find a missing side or a missing leg, sometimes it's called, we are going to move the 22 squared over to the other side to get it ready to get input into our calculator. So we have y squared equals 71 squared, take away 22 squared. Now we're ready to rock and roll on our calculator. Okay, so 71 squared minus 22 squared, you're going to get a fairly large number. 4557, and then use the same buttons as I just outlined. And there are some shortcuts. I'm not going to worry about that right today, just because we only have a certain amount of time to get through things. So we get y is equal to 67.5, and it's meters. And I'm not telling you how to round. Do watch and see if they tell you how to round. Be careful about the rounding. Okay, so there's our basics. So far, just to go back through, we talked about right angle triangles, how to label opposite, adjacent, hypotenuse, how to do sine, cosine, and tangent, finding missing sides, and how to do Pythagoras, finding missing sides as well, because you don't know anything about the angles, okay? So let me throw up a bit of a combined question, and then I'm going to just be quiet for a few minutes and see how we do as a bit of a challenge, okay? So I'll come down here, nice little piece of the board, and I'll draw a picture. I'll just take a minute to pick something out that I know is gonna work out pretty well for us. All right, so let's have a look at something here. Okay, so see how well I can draw something here. Okay. All right, I'm gonna steal something from my Math 20-3 class. So they'll like that if anyone wants to watch it, never mind 20-3. Us 20-2s, this is a good question as well. Now, I'll have to make my board much bigger here for you to be able to read that. So, oh, that didn't cut and paste very well at all. A flagpole is supported by 2 wires, each attached to an anchor in the ground 10 meters from the base of the pole. Oh, I guess that worked. The wires have angle of elevations. Oh, I got to tell you those. The angle of elevations are 37 and 47. So I'll just write that in of 37 degrees and 47 degrees. Okay. So a flagpole is supported by 2 wires, each attached to an anchor in the ground 10 meters from the base of the pole. The wires have angles of elevation of 37 and 47. The question that's asked of us is, how much higher up the flagpole is the top wire? So A, how much higher up the flagpole is the higher wire? So now we've kind of upped the ante here. Before I was just giving you right angle triangles. I was just kind of doing everything here. I just gave you a statement. So again, I'm going to be quiet for a moment. See if you can draw it. See if you can figure out what to do here in these ones. And if not, obviously I'm going to solve this for us so we have a solution. So like I say, I'll be quiet for a moment. So I will draw it. I'm just going to give everyone a little bit of a chance to do it themselves. Okay, so you may have it drawn. I don't want to give you enough time to totally go through it here in case someone's sitting waiting to have a look. So we've got some sort of flagpole. Let's draw the flagpole. There's our flagpole. And a guy wire, or I don't think they call them guy wires, but that's what they are called. There's two wires attaching to an anchor. So here's our anchor over here. And it tells us that the distance from our anchor to our flagpole is 10 meters. So draw that. And then we have two wires going up at different heights. One goes here and one goes up higher, maybe not right to the top, but higher. And then this angle, the smaller angle is 37 degrees. And then the entire bigger angle is 47 degrees. Okay. So that's what this picture could look like. Now, I don't like when they're all together. So once I get my diagram, I feel much happier as a math human, breaking things out and making them separate. So I'm going to just highlight what I'm doing. I'm going to take this smaller triangle that I'm highlighting in blue, and I'm going to do it first here. Okay, so I'm taking it and just the smaller stuff. So then we know this is 10 and this is 37. And then we'll just change the highlighter so you can kind of color code it. Now we're going to look at the higher ones. So the green here, from here to here and over to here. Okay, so that guy, a little taller, same base length. Don't beat me up if my diagram's not perfect. 10 meters, 10 meters, but this is 47 degrees. And it's asking us how much higher up is the second one than the first one. So we need to find this length. I'm going to call it X. And we need to find this length, and we need to just call it Y. If they don't give you letters, put some letters on there that make sense to you. So we're going to have to find X, we're going to have to find Y, and then we're going to have to subtract the two answers. Okay, so it's like a double question. In fact, word question and then worse. So figure out which trig ratios are going to help you out. See if you can find X and find Y. And I'll just sit patiently for a minute while you do that. I'm going to catch up a little bit, but I'm going to be quiet in case you're still working. Just work away. You don't have to look at the board yet. Okay, now I'm going to jump in and interrupt you guys. So you should have hopefully decided it was tangent. Again, if we need a little bit of just background on it, we've got the opposite side because it's directly across from here. My pen has just decided to not work. So X is across from, so it's the opposite. The 10 is adjacent, it's not the hypotenuse, so it's a tangent question. So in terms of what I would like to see for work from any of my classes, you need some sort of starting statement. So tan 37 is X over 10. I'm a little bit agreeable at the grade 11 level to not have the second step show here. Again, my pen for some reason has decided it's gonna not work. Not quite sure why. So the second step where it says X equals 10 times tan of 37, you can leave that step out if you want, and you get 7.5. And then you repeat the same thing for the second statement, tan 47 equals Y over 10. And then we're gonna multiply because the unknown's on the top, and then we're gonna subtract. So see if I can get my pen back to being a happy camper. Doesn't want to work. So we subtract those. 10.7 takes away 7.5. I might have to just stop my share for a second and put it back on. We'll see 3.2. We don't want to have to do that. Let's see if I can get, maybe I can just type the answer up. Okay, so 10.7 take away 7.5, 3.2 meters. Oops. That didn't work. 3.2 meters. Okay, that's kind of small. I apologize. For some reason, my pen doesn't seem to want to work. Oh, there we are. See, just had to give it a little bit of time. So hopefully that's big enough that you can see it. Okay, so now we need to move on into sine law and cosine law. So for 20-3 students, if they're watching this, we're kind of done that. Now we're going to move on. So I would like to ask the students that are here just to jump in, just again, typing to me so that we can keep it kind of off the record, so to speak. Have you started sine law and cosine law? And that is lessons, I think 2 and 3. Module 1, lessons 2 and 3. And don't feel badly if you haven't, because we're just kind of at startup stage, and let me know that as well. So we're going to talk about the sine law and the cosine law for a little bit more time here. Okay, and if you haven't, totally cool, because then that guides along how I introduce it. If everyone says, yep, I've done it, then I will introduce it differently. Okay. So some have finished, some have not, some haven't got started. So we've got a little bit of variety, which is variety is the spice of life. That's okay. So up until now, we've been dealing with right angle triangles. We are able to now work with non-right angle triangles. Now we call these, and a little bit of terminology you do need to know, we call these oblique triangles. Oblique triangles are triangles with no 90-degree angle. And we learn about 2 different theorems. The sine law, usually once you get rolling on, it's pretty fun and pretty quick. Cosine law, decent at times, kind of tricky at times. So it's the one that I try not to use if I don't have to use it. So let's draw an oblique triangle. I'm just basically going to draw a triangle that doesn't have a 90 degrees on it, okay? So we'll call this A, B, and C. Okay, so now opposite, adjacent, hypotenuse mean nothing. Okay, we do not use those terms now that we're on oblique triangles. So we can write that down. No opposite, adjacent, hypotenuse is going to be used here. Those words are not going to be used here. Okay, we're going to use trig, but not quite in that manner. So here's our oblique triangle. Let me give you the sine law. There's a couple different ways of having it written. Here's one way. Sine of A over lowercase a is sine of B over lowercase b is sine of C over lowercase c. And it's 3 parts. We just pick the 2 parts that are going to work if we get a question. You might also see it written upside down. A over sine A is B over sine B is C over sine C. Both of those are nice representations of the sine law. It doesn't matter at all which one you use. Okay. And it's on your formula sheet. So just copy down from the formula sheet. So similar to when we were working with right angle triangles, when we're trying to find missing sides and missing angles, we're also going to do that for the sine law. Okay. So let me write in nice. This is the sine law. So we have it in nice font there. So I'll write another triangle here and we'll play around with the sine law, make sure we're feeling kind of comfortable with the sine law. So we'll do PQR. I'm going to say that this is 22 degrees. I'm going to say this is 35 degrees. And then I'm going to give us that this is 7.3 centimeters. And our question here is find side R, lowercase r. So the labeling of triangles stays consistent. So even though we're not dealing with a right angle triangle, we can say that this is lowercase p. We can say that this is lowercase r and this is lowercase q. Now we don't care about lowercase q, it doesn't come up. So here's how I address these questions. So I'm sure what's going where is I do a little table on the side, just on the left-hand side of where I start my question. So I write down P is 7.3. Angle P is 22, angle R is 35, R we don't know. In order to have a sine law question, we have to have an angle and its opposite side. We have to have some sort of pairing. We have to know angle A and side A, or angle B and side B, or angle C and side C. We need to have one of those pairs. If we don't, it's not a sine law question. Okay, so when we write down our question here, we don't have A's, B's, and C's. I've kind of thrown a loop at us. We got P's, Q's, and R's. We just follow the pattern of the sine law. So we're going to write down sine of P over lowercase p is sine of R over lowercase r. Now we throw our numbers in. So we get sine of 22 over 7.3 is sine of 35 over r. Just tucking everything in there. And then it's just cross multiplying. So sine law, like I say, once you kind of get everything in, I do find that students feel pretty successful in this. So I get r times sine of 22 equals 7.3 times by sine of 35. Divide by sine of 22. These cross out. And now you get your calculator out. Now, just be careful that you close the bracket. Your calculator, as soon as you hit the word sine, is going to open a bracket here. Close that bracket here. Okay. And then I'm going to let you mess around with how to put this in your calculator. I'll tell you the answer here and see if you can get the answer. And if you can't, you can give me some feedback that you can't get it. I'm going to see how good you guys are with your calculator. Don't think this one's too ugly and ornery. I get 11.2 centimeters. I don't think we have anything too bad, but do close that bracket there or you'll get into trouble. Okay, so I think we have 5 or 6 of you here. Just go into the chat bubble and tell me that you can get the 11.2. And if you can't, then let me know that as well. Perfect, 2 of you. Anyone else want to comment? Okay, so we've got that. That's sine law finding a missing side. So again, let's do a sine law where we're finding missing angle. So draw us another funky triangle. XYZ, let's say. And we're going to be asked to find angle, say Z, and I'll give you some information. So we're going to say that this is 41 degrees. This is 12.6 centimeters. And then say this will be 14.2 centimeters. So let's see if we think this is a sine law question, because it's all well and good for us to do sine law. We're going to see in a minute when we do cosine law, things might fall apart. So we're going to write down, just like I did a minute ago, I'm going to write down what I'm told and see what I don't know. So I know that angle X, my pen has stopped working again. So angle X is 41, side X is 12.6. It's kind of hard to do anything when all of a sudden things don't work. Sorry about that, guys. Computers are great until they're not. To identify your side, see if you can write it. I'll just be quiet for a minute and see if I can just write the things on the board. Get another pen, see if that's maybe help me out. There we are. Sorry about that, guys. No idea why that happens. Angle X is 41, side X is 12.6. Angle Z, we don't know. That's what we're trying to find. And side Z is 14.2. So as long as we have pairing, we're good. It's going to be a sine law question. So again, write the sine law that works for us. And you notice I like the angle on top. And if you do it the other way around, totally cool as well. So whoops, I'm going to write the actual formula without the letters in, with the letters in first. Sine X over X is sine Z over Z. And then we'll go sine of 41 over 12.6 is sine of Z over 14.2. Okay, so kind of the same setup, right? We're missing something, cross multiply. So we get sine Z multiplied by 12.6 is 14.2 multiplied by sine of 41 divided by 12.6. Cross this out like that. All right, now we have to do this in 2 steps. We need to go 14.2 times sine 41 divided by 12.6. Again, just the only caution is close this bracket or you run into huge grief. Okay, so let's do that. 14.2 multiplied by sine of 41, close the bracket, and then divide by 12.6. So you get a decimal, right? So we've got sine Z is 0.739368. You don't have to write it all down, but blah, 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 blah. Now, in your calculator, now I'm going to show you something on your calculator that I had alluded to before. If we want that number, see, we've got that big, long, ugly number. We don't want to retype that. We want to take the inverse sine of that. So I'm going to show you the buttons that you can do that, okay? So you got this sitting on your calculator. Everyone right now should have that on your calculator. And the buttons you're going to hit are this: second function sine, and then second function, and the minus button down at the bottom. Right above the minus button, it says ANS, which means answer, and then hit enter. And then that will find you the answer for angle Z. Second function sine, second function, the minus. It cuts and pastes that big long number into your calculator. You can close the bracket if you want, doesn't really matter. And you get, I'm going to round it off, 47.7. We usually like these as kind of degrees, so angle Z is 48. Okay. Whew. Now, maybe someone could come on and quickly tell me how much more time. Do we have quite a lot of more time in your guys' class? I don't know, I don't imagine you guys, too many of you guys bus, but you never know. Don't want to keep you going. I would like to talk about cosine law, but I'm cognizant of the fact I'm keeping you a long time. Okay, not bad. Less than 30 minutes. Oh, I can talk fast. Oh, okay, we're gonna do a bit of cosine law. Okay, and figure out for you guys why all of a sudden we need another law. It's like, good Lord, how much math can they throw at us, right? Well, this is the last thing I'm going to throw at us today is the cosine law. Again, if my pen will work. Wow, it is really not, I don't know why it's ornery. Don't know what I do differently. Okay, so cosine law. Is again for oblique triangles. So these, you know, triangles that look like this. And here's the cosine law. And one of the ways we can write it, there's lots of different ways, but it's sort of like it starts out with, oops, that's an equal sign. Starts out with like Pythagoras, sort of. Notice that the C is not by itself. Okay, there's a version of the cosine law. We need to be really aware and able to play around with the cosine law and write our own. So let's just analyze this briefly, and then we can jump into some questions. So this first parting stage is sort of like Pythagoras, right? Letters are in maybe different spots, but if we're trying to find A, we'd have A over there. And then here, these guys are, I'll use just this times this are the letters that go in here. And then whatever letter is over here is the letter that's over there. So see the pattern? It's just a pattern. It's like Pythagoras, take away 2 times the letters on the same side that are squared, times by cosine of the letter on the opposite side. Okay, so I'm going to get you to practice writing it down, and then we'll check it, because that, so if I have I better put A, B's, and C's on this. That's how it'll work. So let's do a question here. And we're going to try to figure out why in the world we need to cosine law rather than sine law, because sine law, as you see, is not that complicated. And all of a sudden, sine law, or cosine law looks pretty complicated. Okay, so let's draw another triangle. That's just our kind of our formula triangle. Okay, so we'll keep it exciting, PQR. And we're going to try to find, I don't know, side P. Okay, so I'm going to give this as 57 degrees. And I'm going to tell you that this is 14.1 meters. And this is 18.2 meters. Okay, now, as I mentioned back in the sine law, you have to have a set of letters. You have to have angle P and side P, or angle R and side R, to be able to use the sine law. And then the sine law is much, much easier. So let's write down what we know and figure out what in the world's going on here. We know that angle P is 57 degrees. We don't know side P, so we don't have anything matching there. And then we know side R is 14.1. And then we know side Q is 18.2, sorry. See the problem here? We don't have P and P, or R and R, or Q and Q. That's why this is not a sine law question. This is a cosine law question, okay? So now here's your challenge there, ladies and gentlemen. I want you to write your own cosine law and see if you can do it. So it's going to be, we're trying to solve for side P. So it's going to start with P squared equals. Take a second, see if you can write your own cosine law. Follow the pattern in the cosine law that's up there on the board. It's like Pythagoras with an extra term. I don't really want you to, I'd love to have you type that into me, but you don't want to do that. So Give it a go. And just in essence of time, I'm going to jump in here. So it should look something like this: r squared plus q squared minus 2rq cos p. Now, it could be this too. You are not wrong if you went q squared plus r squared minus 2qr cos p. This order of these guys don't matter. Just in case you're kind of frantically going, well, I don't have that. Well, you can have either one of them. So just to keep it easy, I'll use this guy just so you can see, and we won't use this one, but it doesn't matter the order of the letters on the other side. So now we just put everything in. P squared equals 14.1 squared plus 18.2 squared minus 2 times 14.1. I just use brackets here, times 18.2, and then times the cosine of 57. Now, I highly recommend you put that all in your calculator at once and then hit enter. So just really carefully, as it's written, put in your calculator. And I'll tell you what you should get out. And again, if you don't, then you can alert me and I can dig down with you as to what the problem is. Okay, so double check. If you cannot get this, please send me a note. 250.519. Yeah, there's a few more digits there, but as long as you get 250.519, you got the right number. So you can tell me if you got it, but I'm really concerned if you don't get it. We're not quite done, but that's an important number to get out. Now the calculator buttons, if we don't want to clear our calculator, we want to take the square root of that. What we can do is second function x squared, and that cutting and pasting of the answer, second function, and the minus sign down at the bottom, and then hit enter again. And that'll square root the exact answer. And we are a little worried in 20-2 about being kind of exact. So we get 15.8. I'm going to round off meters. Okay, I'm going to slip in one more question. I know I'm going a little quickly here, but if anyone has to leave, feel free. I will post the recording and then you can come back and look at it. But there's one more type of question. So if we're given an oblique triangle, and we'll go back to A, B's, and C's like this. And say we're asked to find a missing angle, and we're given that this is, I don't know, 5, and this is 3, and this is 7, and we'll make it meters. Gosh, that's not drawn to scale. I apologize, but nonetheless, kind of get the idea. Make this 6. There we are. Then it's kind of more to scale. Now on your formula sheet, I'm going to write there's a second way, and again, you don't have to memorize these. There's a second way of writing the cosine law. So I'm going to write that down. So I don't normally use this. So I'm just going to go get it off your formula sheet. So it's exactly the same as what you guys will be exposed to. So it says, right down at the bottom, I think. Yeah, cos A equals B squared plus C squared. So here's what's on your formula sheet. Cos A equals B squared plus C squared minus A squared over 2BC. Okay, so again, it's a pattern, right? So if you need to make up your own, which I think we have to make up our own on this one, this angle and this are what's important, and then the B and the C can go in squared on the top and B and C on the bottom. So our equation we're going to use here is for C this time. We're finding angle C. So we have to reorganize this and rewrite it. So we get cos of C equals a squared plus b squared minus c squared over 2ab. Again, be really conscious that the c here and the c here are the same. We'll write down, make sure we've got everything that it clear. So a is 7, b is 6, c is 5. Let's throw all that into our calculator, or into our formula, and then into our calculator. So 5 squared plus 6 squared minus, oops, no, oh good Lord, fire me, end of the day, need a coffee. 7 squared plus 6 squared minus 5 squared. That looks better. All over 2 times 7 times 6. Now, this one is a challenge to get into your calculator. So let me tell you what to do so we don't have any mistakes. You open up a bracket, you put everything in the top in a bracket, you close the bracket, you hit divided by, you open up a bracket, you put everything in the bottom, you close the bracket, and then you hit enter. Okay, so bracket, everything on top, bracket, divided by, bracket, everything in the bottom, bracket, enter. Let's see how this goes, okay? Because that is really quite the battle. If you don't put the brackets in the right place, it's just a bad scene. Okay, so let's see if everyone can get this out. Oops, I don't need color here. So we get cos of C is equal to 0.7142 ... If you don't get that, give me the heads up. I'll double check. Looks like I got everything. Yep, that's the right number. And then again, the calculator buttons that we're feeling kind of hopefully consistent with are second function, cosine, second function, and that minus button cuts and pastes it, and then enter. So let's do that. Second function cos, second function minus, and we get angle C to be 44.4. They usually ask us to round angles to the nearest degree, so 44 degrees. And that's the last bit of the cosine law.